Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Eka bin Abdul Rahim. Matrix number DF220119. Our group, which is Group 2A, are going to present about Project Hydrology report. These are our group members to complete our project together.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hilmi bin Gamis. My matrix number is DF220218. So now I will present the problem statement. This study aims to determine the average yearly rainfall, peak flow and water discharge in a proposed catchment area in Tangkak, Johor. The data required for analysis come from rainfall and water level station in this region. However, it's important to ensure the accuracy of the collected data by addressing issues like equipment, malfunction, transmission error and gap in the data collection. To maintain the reliability of the data used for hydrological analysis, robust data collection to maintain the reliability of the data used for hydrological analysis, robust data collection method and stringent quality control procedure are necessary. Okay, so now I will present our objective for this project. First objective is to examine the mean rainfall and water level data of each station. Next objective is to measure the terrain profile, gradient slope and cross-section of the water level station using Google Earth. Last objective is to analyze all data obtained using aerial rainfall calculation, hydrograph unit, rational method and Manning equation.
For methodology, we use a sophisticated geospatial software called as Google Earth Pro. It offers measurement tools, high-resolution satellite photos, and data import capabilities. Users can explore the surface of the Earth, measure areas, height and distance, produce visual displays, and input their own spatial data. By using Google Earth Pro, we can find the terrain profile and gradient slope, and also the cross-section for our project. From terrain profile and gradient slope, we can get a catchment area and slope for each path. For path 1, we get 0.25%, and for path 2, we get 0.07%. And for cross-section, we can get from Sungai Kesang at Teluk Limbu.
This is a table of mean aerial rainfall. The table shows the rainfall of each station for 7 days starting from 1 March to 7 March. Based on this table, the highest total rainfall is at station Paya Mas, with the total of rainfall is 223 mm, followed by station Teluk Rimba, 178 mm, and station Kampung Sri Makmur, 141 mm. Each total rainfall will be divided with 7 in order to get an average of precipitation of each station. Therefore, average precipitation in Paya Mas is 31.86, Teluk Rimba is 25.43, and Kampung Sri Makmur is 20.14. After that, we can continue to compute the mean aerial rainfall by using arithmetic mean method, Thiessen polygon method, and isohydral method. Okay, so this is the formula to calculate the average of precipitation by using arithmetic mean method, where P is equal to summation of Pi divided by N, where P is equal to average precipitation, Pi is precipitation depth at gauge within the topographic basin, N is total number of gauging stations within the topographic basin. Therefore, P is equal to 31.86 plus 25.43 plus 20.14 divided by 3. Then we will get 25.81 mm. Another method to calculate mean aerial rainfall is by using Thiessen polygon method. In order to find Thiessen polygon method, we need to find the area of each station beforehand. By using Google Earth Pro, we found that the area at station Paya Mas is equal to 6.59 km², station at Teluk Rimba is 10.1 km², and station at Kampung Sri Makmur is 4.57 km square. So the total area of this studied area is equal to 21.26 km square. Then we need to multiply with the average precipitation at each station. Then we get 209.96 at station Paya Mas, 256.84 at station Teluk Rimba, and 92.04 at station Kampung Sri Makmur. Sum it up, then we will get 558.84. After that, put in all the information that we already calculate into this formula, where P is equal to summation of polygon area for each station times precipitation divided with summation of total polygon area. Therefore, we will get 558.84 divided by 21.26, then we will get 26.29 mm for average precipitation by using Thiessen polygon method. Okay, lastly, this is the formula in order to find precipitation depth by using isohydral method, where P is equal to summation of AI times PI divided by summation of A, where P is equal to average precipitation depth, PI is average precipitation between two isohydral lines, AI is equal to sub-area between two isohydral lines, and summation A is the total area. Okay, to find average precipitation by using isohydral method, we have to divide our catchment area into several parts. Based on figure above, we already divide our catchment area into 5 parts. Then, calculate the sub-area between two isohydral intervals, sum it up, then we will get 21.26 km square for the area. After that, compute the value of area times average precipitation for each interval. Add it up, then we will get 559.11 km square mm. Put it on the formula, then we will get P is equal to 559.11 divided by 21.26. Therefore, P is equal to 26.3 mm.
Hi, my name is Nunada binti Marazib and I will talk about hydrograph. Hydrograph is a graph that plots various water flow against time. By construct graph, total flow versus time. To determine discharge, we use many methods. So this is the upstream for water level at Sungai Kesang. The highest discharge depends on the highest water level. Discharge for upstream is 20122.01 meter cube per second. This is the midstream for Sungai Kesang River. The highest discharge that we got is 66720.38 meter cube per second. For the last hydrograph is downstream for Sungai Kesang River, and the highest value for discharge is 36531.194 meter cube per second. For rational method, we plot IDF curve due to the travel time that we calculate is 310.41 minutes, and for the rainfall intensity we got 26 mm per hour. For peak flow, we got QP is equal to 3595.05 meter cube per second, and I is equal to 185.10 mm per hour. This is the cross-section for upstream, midstream, and downstream, and we calculate every parameter each of them. This table shows the calculation of discharge of each cross-section. We take 3 highest discharge. The first one is the highest discharge from upstream, section 2 is from midstream, and section 3 from downstream. In this section, we highlight the second section because it is the highest value.
Assalamualaikum warahmatullahi wabarakatuh. My name is Khairul Aziz Farhan, F190201. I will present on the discussion and conclusion part for this project. Calculation of average rainfall in a catchment area are using 3 methods, which is arithmetic mean method, Thiessen polygon method, and isohydral method. Arithmetic mean method is a crude and rarely used method. Thiessen polygon method is superior as it considers representative areas for each rain gauge, giving weightage to different stations on a rational basis. Isohydral method is suitable for all types of catchment and estimate mean precipitation by drawing line of equal depth rainfall called isohydral. Result of the average precipitation calculation for arithmetic mean method is 25.81 mm for Thyssen polygon is 26.229 mm and isolatal is 26.30 mm. From the result of these three methods, none of the methods consistently provide a better estimate, but rather alternates between the three. For the peak flow calculation, we use many equation and rational method. The result from many equation is 411 to 4.78 meter cube per second, while for rational method is 3595105 meter cube per second. The two methods yields different values, indicating that there is error and limitation in the analysis. Use of rational method for peak flow data. Rational method is chosen due to its larger method area, and the peak flow calculated using the rational method is estimated to be the same as the result in the analysis. It is important to collect sufficient data because the data is useless if not collected in large quantities. In conclusion, the Earth's surface is covered in vast amount of water, forming the hydrosphere. Water exists in solid, liquid, and vapor forms, and it flows between different reservoirs. This movement is driven by solar energy, temperature, atmospheric pressure, and water vapor. Key processes include evaporation, transpiration, precipitation, runoff, and groundwater. The hydrological science focus on measuring the rates of water movement and the amount involved in cyclic process. The global water circulation, known as the water cycle, encompasses various process and causal system. Understanding the hydrology cycle, its component, and estimating water balance are crucial. Measurement methods such as stream flow, infiltration, and evaporation help determine the speed of water movement in specific areas. By studying this process, we gain valuable insight into Earth's water system.